role of d in a sinusoidal function. So we have these four possible changes that can happen in our sine and cosine equations. We've already figured out that the a in the equation controls the basic shape as well as the amplitude, and we've determined that the b impacts the period. What about adding a number to the end, this plus d? What impact will that have on the graph of this equation? Well, let's go to the calculator and do some investigating. The first thing I'll do is put in my regular basic sine function, and I'll use the z-trig option. And so this blue graph is just y equals sine x. Let's now add in y equals sine x plus 2. This one will come up in red. Let's see what happens as I hit the graph. So you can see it has the same basic shape, but it's been shifted upward. It's as if somebody took the blue graph, picked it up, and moved it up a certain amount. We call that a vertical shift. Let's see, how many spaces did it move up? Well, the high point used to be here at 1. Now it's up here at 3. So it looks like it's been shifted 2 spaces up. That makes sense. We did a plus 2 on the end. In terms of our key features, what has changed? The one that stands out to me right away is the midline. The midline has always been here along the x-axis, the horizontal line y equals 0. Clearly it's up higher now. Let's see, the middle spot would be right here at 2. So it looks like the midline is now the horizontal line y equals 2. As far as the rest of the information, I think it's unchanged. The distance from the midline to the top is still 1. You can see this thing still repeats after 2 pi, just like it did before, so the period is unchanged. It makes sense that the amplitude and period didn't change. I mean, look at the equation. There's no multiplying number in the front of it, which means the a is 1, so of course the amplitude is 1. Look at the x. There's no multiplying number in front of that either, so nothing changed the period. The period remained 2 pi. The only thing that changed was the midline because of the vertical shift. So that was an example where d equals 2. Look at this second example, y equals sine x minus 1. Now the d value would be negative 1. This is where the model is so important. There's a plus here in the model. The only way that could turn to a minus is if somebody put a negative number here. So the d must be negative 1. Well, you can probably guess what's going to happen. It's probably going to be something similar. But let's take a look at the calculator. I'll go back to the y equals. I'll get rid of that previous second equation, and I'll put in sine x minus 1. Make sure to use the minus button, not the negative button. And we'll add that to the graph. And again, I'm sure you're not surprised. It looks like there's been another vertical shift, this time in a downward direction, undoubtedly because of the negative sign. You can see very clearly it's moved down 1 unit because of the minus 1. The period and amplitude are once again unchanged. The midline, though, has changed. Let's see, for the red graph, the middle spot is now right here at negative 1. So the midline would be the horizontal line y equals negative 1. Even just doing 2 examples, the pattern is pretty obvious here. I think we're ready to summarize the role of d. d is the vertical shift. Specifically, if d is positive, the graph will shift up. And if d is negative, the graph will shift down. The other thing we want to say is that d impacts the midline. Specifically, y equals d is the equation of the midline. These are the things you want to take away. Thanks for watching.